Welcome to the IoT Security Foundation monthly webinar for September 2025. It's been a busy week. We had a delegation at the Things conference in Amsterdam earlier on this week. We're also currently at the Microelectronics exhibition at the London XL. That's where I am right now. And just a few hours ago, we had an event in Melbourne too. Not only that, our annual conference at London's IET is just over a month away. And this year, it's a joint conference with TechWorks AI. So if you like, two conferences in one day at one venue. The only sponsorship opportunities now left are sponsorship of the event goodie bag and sponsorship of the event registration desk. Exhibiting is sold out. Register now for the world's longest running IoT security conference. For the agenda, for the speakers, the remaining sponsorship deals and anything else, go to IoTSF-AI.org. I'll put that link in Zoom chat in just a few moments. And if you're watching this on YouTube, I'll also put that link in the description. Up next is Chris Swan of Atsign. In 2022, Atsign won the IoTSF Champion Award at the annual TechWorks Awards and Dinner. So they're a company that we rate highly and, of course, respect and admire. If you have any questions for Chris, please put them in Zoom chat. His talk is entitled Software Supply Chain Security, SBOMs, SLSA and Scorecards. Chris, the floor is yours.
Thanks, Chris, and hi, everybody. So a question that we hear a lot normally at the stage of conversation with customers where they've decided that they want what we are trying to sell them is, how do we know that you're secure? And I think this is a question that your customers are probably asking you. And it's also a question that we're kind of asking as we look up the supply chain. So, as we think about the dependencies that we're putting into our software, how do we know that that's secure? And hence, how do we know that we're delivering an overall secure experience to our customers? So I'm going to be talking about three things. So SBOM is software bill of materials. SLSA is supply chain levels for software artifacts, and scorecard. And collectively, these are three things that can be used to articulate security of a software supply chain. And I'll also try and illustrate that they're not standalone, that each is kind of interdependent on the other, and that by doing work in one area, you're easing the work in other areas as well. So hi, folks. I'm Chris. I'm an engineer at Atsign. We've built a platform that provides private and secure connectivity. And there's an application that we sell called NoPorts, which provides secure connectivity between arbitrary points, used a lot in the IoT space for things like secure remote access, particularly things like IoT gateways. So what I'm going to be talking about today is a kind of cooking and kitchen analogy to how we do better security. And this really relates quite well to what Yogesh has just been talking about in terms of secure by design, because the secure design by design principles underlie a lot of what's happening here. But if we think about, how do we trust what we get from a restaurant? Well, we trust that they're gathering good quality, tasty ingredients. We trust that they're preparing those ingredients into meals with suitable attention to detail. And we trust that they're ensuring the hygiene of the kitchen and that everything is being made in a good quality, reliable environment. And so if we transpose these things that we trust in the kitchen to the world of software, when we're gathering ingredients, we can articulate our ingredients in a software bill of material. When we're building software artifacts, we can have attestations of that with SLSA. And when we look at the overall environment that we're using to construct software, we can have an open source security foundation scorecard that will tell people about the various qualities of that environment so that they know that it's a good environment for creating and maintaining software. So I just mentioned the Open Source Security Foundation, also known as the OpenSSF. This is a part of the Linux Foundation, and it's the part of the Linux Foundation that has kind of taken responsibility for the various things working on open source software security. And many of you watching this might be thinking, well, I'm not doing open source, so why should I care about open source security? You might not be building open source, but you're almost certainly using open source as part of your dependencies for the things that you're building. So even if you're not producing open source itself, you can make use of these tools to look down your supply chain to ensure that you're getting good quality open source as part of things that you're packaging up for your customers. So starting then with software bill of materials, also known as SBOM. The link I've given here is to the United States Cyber Infrastructure and Security Agency, known as CISA. And that's because they've been taking a leadership role in bringing software bill of materials to the world of software construction and maintenance. And that came about because of an executive order in the Biden era. So that was EO 14028, entitled Executive Order on Improving the Nation's Cybersecurity. And essentially what that executive order says is that for people selling software to the US federal government, that software must come with a software bill of materials, and that the buyer of that software is going to be looking at that software bill of materials to ensure that there's no known vulnerabilities in that software. Because why would you want to buy software that's got known vulnerabilities in it? And why would you want to be trying to sell something to the federal government that has known vulnerabilities in it? It would certainly be a strong point of price negotiation if you were trying to push software that had known vulnerabilities, but much better to actually deal with those vulnerabilities and be selling stuff that at the time of sale, at least, is known to be not carrying any known vulnerabilities. Now, the wind has gone a little bit out of the sails of this because of the change in political climate in the US. And some of the key people involved in driving the CISA initiatives around SBOM have left the agency and are moving on to other activities. But just as that's happening, we see Europe kind of picking up the baton. And so Yogesh mentioned in his presentation the European Union Cyber Resilience Act, the EU CRA. And this is something where the clock is ticking towards implementation. So this was published almost a year ago, and the implementation of some sections starts next year in 2026, but full implementation starts in December 2027. One of the things that the CRA mandates is that people selling software must publish a software bill of materials that must include at least the top level dependencies in a machine readable format. And one of the keys here is the fines for breach of the Cyber Resilience Act are along similar lines to the fines for GDPR. And so that's 15 million euros or 2.5% of worldwide turnover, whichever is higher. So potentially very hefty fines. Now, just as with GDPR, we're not expecting the EU to be waving a big stick around on this immediately after implementation. There will probably be something of a settling in period for it. But there is only a couple of years and a couple of months to get ready for this. The OpenSSF's got some excellent guidance and also a training package relating to this. And so that's why I've put a link to that on this slide. Once you start getting into software bill of materials, you'll find that there's two competing standards. So there's Cyclone DX, which comes from OWASP, who have a long tradition in software security. And there's SPDX, which comes from the Linux Foundation and now lives inside of OpenSSF. So SPDX started out being a standard for license compliance. And if you look at some very diligent open source projects, they'll have SPDX identifiers in literally every file in a repository. But SPDX has subsequently grown to be a standard that can express the dependencies and be used for software bill of materials. And in fact, it doesn't really matter very much whether you're using Cyclone DX or SPDX. All of the relevant tools are quite capable of creating and ingesting both. And so when it comes to those tools, it's possible to make an SBOM with tools like Sift and Trivy. Both of those are openly available. And it's possible to consume an SBOM with Guac. Guac is another OpenSSF project. So that will ingest feeds for vulnerabilities, then look at an SBOM and tell you whether you've got vulnerabilities inside of it. All of this stuff is super easy if you're using a modern package managed language. So, something like Node or Java, or we use a lot of Dart, Python, etc. They're all good. They'll give you a package lock file, and Sift and Trivy will happily turn those into an SBOM. It's not so much. That's not so much though with traditional embedded. So if you're writing stuff in C and C++, you probably don't have a package manager. For our stuff at Atsign, we've adopted Conan, which is a package manager for C and C++. And we can generate SBOMs for our C stuff from the lock files in Conan. But that's not something that's in very widespread use. It's a huge problem, especially for IoT. So if we look at lines of open source code, C is now north of 6.8 billion, C++ 2.3 billion, and Rust, which is where everybody's kind of putting their bets for security, still languishing kind of almost 2 orders of magnitude behind at 70 million lines of code. Now, that number has come up a decent amount since I last looked at it back in February. And also, it's worth noting that people are using Rust for security critical functionality. But if we're expecting the widespread use of C and C++ to be rapidly displaced by Rust, that's going to take an awfully long time to make up that enormous gap. What can help a lot are Yocto and Zephyr. So these, again, are Linux Foundation projects. Yocto is a meta Linux distribution, so it lets you make your own Linux distributions. And this is quite popular for IoT systems built on system-on-chip type of environments, whereas Zephyr takes care of the more constrained microcontroller type of environments. In both cases, they've got full visibility of the dependencies that are being used, and hence are able to generate a software bill of material for you. So just as with the package management environments, a package manager kind of gives the lock file that we can generate from. These are essentially package managers in their own right, and so they can do the same. So moving on then from the ingredients to the prep, we have supply chain levels for software artifacts known as SLSA, and you can get the information on that from salsa.dev. And this is concerned about the full range of supply chain threats. So it's looking at threats coming from source code, it's looking at threats coming from dependencies, and it's looking at threats that can be potentially injected at build time. Now, implementation of SLSA at the moment is mostly focused on build levels, and they define essentially 4 different build levels. Now, build level 0 is really, nothing's happening there, whereas build levels 1 through to 3 are kind of ratchet of increasing hardening and anti-tampering as a result of the attention that's being put to this. Now, for people using continuous delivery pipelines, and especially those doing that within modern source control environments such as GitHub, GitLab, etc., It's possible to generate SLSA build attestations as part of the continuous delivery pipeline process. And so achieving build level 3 is relatively straightforward if you've already got a well-contained continuous delivery environment. So then kitchen hygiene takes us to Scorecard. This logo is from the OpenSSF Scorecard project. And a scorecard badge looks something like this. So this is one that I've taken from a repo showing a scorecard. But what's behind the badge? Well, scorecard is trying to do a sort of automated set of tests across holistic security practices. So it's looking at whether there's any known vulnerabilities in code. It's looking at how the code is maintained. So are there multiple people working on the code? Do they have good practices in place, like branch protection? Are they doing testing? Is that continuous? So is there evidence of continuous integration tests? Is there some knowledge of source risk assessment? And is there a build risk assessment? And that looks into things like are the aspects of static source code analysis and dynamic source code analysis taking place as people are building their artifacts. A big part of it turns out to be about dependency pinning, and this can result in a bit of dependency pinning hell. And so for dependencies like Docker, Go, GitHub Actions, Node, pub.dev for the Dart ecosystem, and Flutter, PyPI for Python, all of those dependencies can be pinned against specific shards. And the scorecard checker will be looking to make sure that those dependencies have been pinned and raising flags if they haven't. And that in turn brings up a dependency maintenance problem. But that makes sure that people are being diligent about and being on the latest versions of dependencies which are secured against known vulnerabilities. And it works out to be a bit of an 80-20 thing. So you can get a green scorecard with a score of 8 out of 10. So 80% of the work, and that takes about 20% of the effort. So it's relatively easy to get most stuff right. If we look at a scorecard here with a score of 8.9, we're seeing 10 out of 10 for a whole bunch of the checks. No binary artifacts, CI tests in place, code review in place, a variety of contributors, no dangerous workflows, dependency update tools, licenses, that it's maintained properly. But there's always going to be some residue. I've yet to see a project with a score of 10. And so putting in place things like static analysis can be a little bit fiddly. Putting fuzzing in place can be very difficult in some environments if there's not a well-known fuzzing package for the languages and frameworks that you're working with. And then things like CII best practices, that's used to be the Common Infrastructure Initiative, now also part of OpenSSF, is a very long and detailed questionnaire. And just taking the time to fill that out is one thing, but actually doing all of the stuff that it demands, and especially getting to a gold badge, is a great deal of effort. And there are very few projects have accomplished that. But I'd call out Curl as one where they've kind of gone to that effort. And Daniel's led the team there to doing an outstanding effort. So this is what the bottom of the chart might look like to consumers. Maybe all of the dependencies aren't quite pinned. Maybe getting branch protection fully in place and multiple sets of eyes on every change is impractical, especially for smaller teams. Getting just the pass on CII best practices will only get you a 5 out of 10. You need the gold badge for 10 out of 10, and that's very hard. And fuzzing might not be available in the language that you're using. That can also be plotted as a radar chart, and that's a good visual way of taking a look at a scorecard. And as I've mentioned already, it gets really gnarly with the best practices. So very detailed set of questionnaires and lots of work to be done behind that. So in review then, a software bill of materials is equivalent to knowing that you have the right ingredients. Supply chain levels for software artifacts, SLSA, shows that you're taking care in preparation. And scorecard is like ensuring kitchen hygiene. We've probably all glanced at those hygiene stickers outside of restaurants that we might be considering going into. And who wants to go into a restaurant that's got a poor hygiene certificate? Some resources here. So various blog posts, the @GitHub page in our repo for the README there kind of shows how we're using some of these tools and has links to our scorecards. And then Varun Sharma, who's the co-founder of Step Security, has a repo there that he put together for a talk that he did at QCon a couple of years back, which I think helps people with some of the automation to put scorecards in place. So thank you for your time. You can reach me as chris@atsign.com or on all of the socials as @CPSwan. And I think it's time for questions. So back to Chris.
Thank you very much for that, Chris Swan. Please be aware that I'm currently in London at the Excel for the Microelectronics exhibition. So if there's a bit of background noise, that's the reason why. So as I said previously, there won't be an IoTSF webinar in October as it would clash with our annual conference. So the next broadcast from us will be on Thursday, the 6th of November, and we'll have two presenters from ZF. They will be Alan Jacobs-Cook and Sergio Scarbar as well. If you're watching this live, the link is in Zoom chat right now. Just scroll back a little bit. And if you're watching this on YouTube, the link will be in the description. So I'm just going to fiddle around just so that I can get everybody on screen properly. Bear with me. And Yogesh is back as well. So let's get the Q&A underway, and Yogesh, I'll bring you back in. How is artificial intelligence transforming offensive IoT security research? What are the key impacts and strategic advantages of integrating AI into offensive security methodologies targeting IoT ecosystems?
Okay, the role of AI is like in the offensive IoT security is like it's a kind of revolution in helping as a companion for us. Like we haven't imagined like it will help in automating vulnerabilities, discoveries, exploit like writing exploit codes, like exploit generation for through AI. Then behavioral analysis is like kind of easy task for us for now that we haven't think of like we can imagine, and then we have it enables faster, scalable, and more precise attacks like on the connected devices, basically by analyzing what kind of protocols and what kind of network emulation, whatever things present at that particular level. And then AI adaptation to evolving ecosystem for the IoT, having high value target with efficiency, like attacking on some target for that particular thing. So we can make things in a better way, basically, with the use of AI.
Thank you very much for that, Chris.
Yep.
I think this question is for you on Zoom chat from Vinay. In continuation of using open source software, does CISA/SPDX have strong requirement or guidelines which enforces OEM to provide latest software with release timelines and mandatory plans? Or is it left to the OEM to gauge the risk and decide it?
So a few different moving parts there. So the formats like SPDX and Cyclone DX are just kind of carriers for information about dependencies. There's a thing called NTIA minimum standard, which comes from the National telecommunications agency in the US, which kind of predated CISA. And CISA are now in the review stage for a new minimum standards for SBOM, which I think will become the kind of commonly accepted standard. And so that's about enhancing and augmenting an SBOM with details about the supplier and a whole host of other metadata, which actually comes from beyond the log file for the dependencies. So when we're creating SBOMs at Atsign, we use a platform called SBOMify, which lets us take our log file, generate the SBOM from that, but then enhance it with lots of details about who we are at Atsign and where you can find us and all of those kind of details. Now, I think CISA, once they've decided those minimum standards, that's what they'll be insisting on for the federal government as they're implementing that executive order. If we look across, though, into Cyber Resilience Act, it doesn't have that same concept. But what CRA has that kind of doesn't happen with the executive order is much more of a notion of, if you've got known vulnerabilities in your software, then you ought to be patching them. And there should be an automated update process for your software. And you have to do those patches for like 10 years after the release of it. So there's quite a lot of requirements in CRA in addition to publishing the SBOM. So then they're not yet saying that the SBOM needs to have lots of additional metadata in it, just that it needs to be machine readable. But there are other aspects of that legislation saying that suppliers will be on the hook for making sure that their software is updated in a timely manner, and that customers are able to get hold of those updates. An interesting thing there is they're also separating functional updates from security updates. So this practice that's become commonplace of kind of forcing changes onto customers in order to get security updates, they're kind of standing in the way of that and saying, no, customers should be given a choice over functional changes, but still able to get hold of security changes. And that's going to become quite complex to manage, I think, for a lot of organizations.
All right, thanks for that, Chris. Yogesh, what lies ahead for offensive security in the age of IoT, industrial IoT, and OT?
Okay. Just like IoT, like attack surface are expanding across the consumers, industries, and operational technologies. So expecting AI-driven red teaming, then supply chain attacks and cross-domain attacks will be increasing. So this is the future for the offensive IoT security experts for doing red teaming with help of AI-driven thing. And then offensive security will shift from device level to ecosystem level. So it depends upon what kind of environment we have, like from the chip to cloud level. So it will involve everything in that.
All right, thank you very much for that. Chris, I'll come to you. How can I use an SBOM to tell if the software that I'm using is vulnerable?
So there's a bunch of tools out there, but I would generally point people in the direction of GUAC, which is an open source tool that is part of OpenSSF. So GUAC will let you ingest an SBOM and also take a whole bunch of vulnerability feeds and figure out whether you've got a vulnerability inside of your dependencies. That still leaves a bit of work to be done, though, because are you actually affected by that vulnerability? Is your software running that bit of code? And that requires more sort of in context understanding of the code paths and how a particular application is using them.
Yes, thank you very much. Yogesh, bringing you back in. What is the most effective strategy for conducting offensive research on connected devices?
Like to make it very effective, like doing offensive research must be a methodological, creative, and adaptive in nature, like mapping assets with the different consumers and the third-party integrations, like analyzing protocol, what connected, what not connected, then performing reverse engineering firmware analysis and hardware analysis for doing the effective stuff like getting the vulnerabilities out of that. Then development of exploit for particular vulnerability will help to minimize the flaws in the next releases. Then we have like there is a good success rate depend upon the blending of technical skills with the creative mindset for that particular thing.
Thank you very much for that. And one last question for yourself, Chris. Let's say most of my key dependencies don't have scorecards. Can I just run it myself and see how they're doing?
Yes, you can. So for repos that are presenting scorecards, they'll normally be doing that with a GitHub action and running the scorecard and uploading the Serif file that gets generated to services behind the scenes. But for any open source software, you can run a scorecard against it by just downloading the scorecard command line tool, giving it a GitHub token and pointing it at the repo that you want to analyze. And so this is one way that we can be diligent about our supply chain is we can look at our dependencies. And if they don't publish a scorecard, we can figure it out for ourselves. And it'll normally be terrible because the very presence of a scorecard will usually show that people care about security. And contra, if they haven't put one there, it's probably because they haven't even thought about it.
Thank you very much, gentlemen. That's all we've got time for. I'm conscious that in Pune it's actually early evening, so I'm very grateful to you, Yogesh, for giving up part of your evening. So much obliged to you. And Chris, it's been an absolute pleasure to have you back in the IoTSF mix. Thank you very much for your presentation today. So one last thing to mention before we go. As I said at the top of the broadcast, our annual conference at London's IET is just over a month away on Thursday, the 30th of October. This year it's a joint conference with TechWorks AI. And if you would like to be there, register now, please. Go to IoTSF-AI.org. This is the world's longest running IoT security conference. And for the agenda, the speakers, remaining sponsorship deals, and anything else, please, like I say, go to IoTSF-AI.org, and we will see you on Thursday, the 30th of October at London's IET. In the meantime, my sincere thanks to Chris Swan of Atsign and from Johnson, Yogesh Kakadwar. Thank you very much, gentlemen. And we'll be back with another in the IoTSF's monthly webinar series on November the 6th. If you're quick, open the link in Zoom chat right now before we disappear and register, and the link will be in a new tab. Right, that's it. Bye for now. Thank you very much.